So in this video, I'll be going through the June 2018 higher paper 2. Let's make a start. Question 1, we have an inequality. 14n is greater than 11n plus 6. If it makes your life easier, instead of the equality, you can treat it as an equal sign for now. So 14n is equal to 11n plus 6. We can subtract 11n from each side. That gives us 3n is equal to 6. We can divide each side by 3. That gives us n is equal to 2. And now remember to put the inequality back in. So that's going to be n is greater than 2. Next one. On the number line below, show the following show the set of values for x. So minus 2 is less than x plus 3 less than or equal to 4. So you can treat these as two separate equations. So there's this bit here, and then there's this bit here. So if you start by looking at this, that's going to be minus 2 less than x plus 3. We can subtract 3 from each side, and we're left with minus 5 is less than x. And now if I look at this side of the equation, that's going to be x plus 3 is less than or equal to 4. If I subtract 3 from each side, I'm left with x is less than or equal to 1. So my answer becomes minus 5 less than x less than or equal to minus 1. So I'm going to draw a circle at minus 5, a circle at minus 1. Sorry, not minus 1. That should be 1. Now I'm going to fill in the circle at 1 because there's an equal to sign there. And then I'm going to draw a line that joins the two together. Moving on to question 2. On the grid below, draw the graph y is equal to 2x minus 3 for values from minus 2 to 4. Okay, they've told us the values they want us to plot the graph for. So with the graph, the equation of a line is y is equal to mx plus c. C is the y-intercept, so in this case it's minus 3, so that means this line is going to cross the y-axis. If I just change colour for a second, at minus 3, so we know there's definitely going to be a coordinate there. And then the gradient is 2, so that means for every 1 we go across, we go 2 up. So for every 1 we go across, so in this case, on the x-axis, it goes up by 1 every 2 squares, so just watch out for that. And in the y-axis, it goes up by 1 every 1 square. So it's just worth bearing that in mind. So we're going to go 1 across. For every 1 we go across, we go 2 up. That's what the gradient of 2x means. So the next point is going to be there. So we wanted us to plot the points from minus 2 to 4. And then hopefully you can see the pattern. It will be the same going forward. So we're going to go 1 across, and we're going to go 2 up because the gradient is 2x. So the next point is going to be here. Sorry, not there. That's what I meant. And again, 1 across, 2 up. 1 across, 2 up again. And then for the minus 1 point, we're going to go 1 across, 2 down, just down here. You can see it's following a pattern. And that's going to be the other one. So we have now plotted the points from minus 2 to 4. We're going to use a ruler and draw a straight line through them. So we're going to connect them 2 points together using a ruler. And draw a straight line straight through them like that. Put the ruler away. Moving on to the next one. Hanan is planning a day trip of 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. The table below shows information about the results. Work out how many of the 195 people you think will go to the theme park. So theme park is that one there, so that's going to be 10. Out of the 30 people she asked, I'm going to multiply that by 195, and you can type them numbers into your calculator, and that gives you 65. State any assumption you made and explain how this may affect your answer. So an assumption we're making here is she's only picked 30 out of 195, so we're assuming the sample is random. Sample is random. I'll explain how this may affect your answer. So we're assuming that the sample is random. Otherwise, the answer is biased. Something like that. For example, if you just picked 30 students in her class, maybe everyone in her class wanted to go to the theme park. So moving on to question 4, a container is in the shape of a cuboid. The container is 2/3 full of water. A cup holds 275 ml of water. So we know it's 2/3 full. Each cup holds 275 ml of water. What is the greatest number of cups that can be? It's important to note the wording here. Says completely filled. That's going to be key. So the first thing you're going to do is work out the volume of this container. So the volume is going to be the cross section. So that can be like that cross section, which is going to be 19 times 6. And then you're going to multiply that by the length. Again, it's a calculator paper. Type them into your calculator. And you get 3,420 centimeters cubed. And now it's saying it's only 2/3 full, we've been told there. So we're going to do 2/3 times 3,420, which is 2,280 centimeters cubed. And now a cup holds 275 ml of water. So we're going to do 2,280. That's how much is in the container. So that's 2/3 full. And each cup holds 275. And that gives us an answer of 829. So we're going to need 8.29 cups. But it says, what is the greatest number of cups that can be completely filled? So that's going to be 8 cups. So 8 cups can be completely filled, and you would write that down there. So question 5, you have a right angle triangle, calculate AB. So we can start by labeling the side. So this is going to be the opposite. That's going to be the hypotenuse because it's opposite the right angle, and that is your adjacent. Now it's asking us to calculate the length AB, so we're going to need that one. If we know something here, that's 16, we know nothing about the adjacent, so we can cancel that out. That leaves us with O and H, and that's going to be something like this. So we have sine 38 is equal to the opposite, which is AB, divided by the hypotenuse, which is 16. So the answer for the opposite is going to be the 16 times sine 38, and opposite obviously is AB. Again, you type the numbers into your calculator and you get your answer as, into 2 decimal places, as 9.85. And then it says, Sally used a calculator to work out the value of a number y. The answer on her calculator display began in 8.3. So she's got on her calculator, just imagine that's a calculator. The answer that she's gotten is 8.3. We don't know the rest, but it starts with 8.3. Now, complete the error interval for y. So the lowest number must be 8.3 because that's what she sees. And then the highest number, not exclusive, will be 8.4. So that means it can be something like 8.39. That will round to 8.4. This is question 7. So 360 pounds is shared between 4 people. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. Chloe and Dinesh get 1.5 times the amount Abby gets. Work out the amount of money Ben gets. Again, it seems like a complex problem, but let's start by listing out what we have. So it's shared between Abby, Ben, Chloe, and Dinesh. So that's from that line there. If I now look at the next line, it tells me Abby gets 2 to 7, Abby, the ratio of Abby to Ben. Then it says Chloe and Dinesh get 1.5 times the amount Abby gets. So we know Abby gets 2. So if you do 2 times 1.5, that's going to be 3. So that means that's going to be 3. And that's going to be 3. Work out the amount of money Ben gets. So Ben is right there. Ben gets 7 shares out of a total of 7, 8, 9, 10, 11, 12, 13, 14, 15. So this adds up to 15. In total, he gets 7 out of 15. We're going to times that by 360, which is the total amount. Again, you can type those into your calculator and you get 168. Moving on to the next one, write 0.0562 in standard form. So in standard form, we're going to hop the decimal 3 times to the right. So that becomes 5.62 times 10 to the minus 3 because we hop 3 times to the right. The next one, we're timesing it by 10 to the power of 3. So hop the decimal 1, 2, 3. That becomes 1452. Moving on to question 9, the circumference of circle B is 90% of the circumference of circle A. So if I just, as a quick reminder, that's a circle, and the circumference of a circle is just the area outside, the length of the distance outside, so the circle itself. So we know that we have A and we have B, and if A is 1, B is 0.9 in terms of the circumference. I'm not going to write the full word. Find the ratio of the area of A to the area of B. Right, so the first thing we want to do is find the scale factor between the two. So how do I go from here to here? Now, in order to go from 0.9 to 1, we'd have to times it by 10 over 9. But that's a length scale factor. Circumference is a length. Now, to get the area scale factor, we're going to have to square that. So we're going to do, for area, that's going to be 10 squared over 9 squared, which is 100 over 81. So that means for area, if area is 1, this is going to be 81, 0.81. And then if you want to write that without the decimals, we can times each side by 100, so that'll be 100. So 81. And it's asking in the ratio 8. Yep, that's it. So find the scale factor for the circumference, which is the distance. Find the scale factor, which is 10 over 9. Then square that scale factor to get the area scale factor. And then that's basically telling you how you're going from here to here. And it's saying, well, to go from here to here, you're timesing it by 100 over 81. So then that must be 0.81. So it says the square E has sides of length E centimeters, square F has sides of F centimeters. The area of square E is 44% greater than the square area of F. So we have two squares. I just draw that here quickly. We have E, and then we have F, which is a bit smaller. So it's saying it's 1.44, it's 44% greater. So that becomes 144% because percentages have 100. So if this is 1, this is 1.44. If you talk in terms of decimals, which you can then write as 144 to 100 if you times each side by 100. And that's where that came from. Remember, percentage is always out of 100. So it's 44% greater, so it's going to be 144%. Cool. So now that we have that, we can simplify this. So we can divide each side by 2. And then if you keep simplifying it down, you end up with 36 over 25. Remember, that is the area ratios. And they haven't asked for the area ratios. They have asked for the ratio of E to F. So the ratio of E to F, we can square root each side. And that will become root 36, root 25, which then becomes 6 to 5. Moving on to the next one. So now, Mary travels to work by train each day. The probability that her train will be late on any day is 0.15. Okay, probability is always out of 1. So to work out the other one, it will be 1 minus 0.15. So that's going to be 0.85. And then the probabilities are going to be the same across the day. So the probability that she's late on any other day will be the same as well. So we can just copy that across. So that's that done. And then it says work out the probability that the train will be late on at least one of those 2 days. So what it's basically saying is it's either late and then not late, or it's not late and then late. So if you look at, for example, the blue line, I'll just use a blue pen for this so it makes it a bit more clear. If I look at the blue line, we are doing 0.15 times 0.85. So that's the probability of being late and then not late. And if you look at the green line, that's 0.85 times 0.15. And they both are going to be equal to the same. And if I just change my color to keep it consistent, and then you just add the two together. So you add them two together and you end up with 0.2. If I just write that in the box, 0.255. Group frequency table shows information about the times in minutes that 80 office workers take to get to work. Complete the cumulative frequency diagram below. So for the cumulative frequency, we're just adding the previous number together. So that's just going to be 5. That's going to be the previous number, which is 5 plus 30. So that's going to be 35. And similarly, this is going to be 5 plus 30 plus 20, which is going to be 55. And the next one is going to be 70. Next one is going to be 78. And then the next one is going to be 80. And then it says on the grid, draw the cumulative frequency for the information. So you always want to plot against the end of the times. So for this, we're going to plot 20 against 5, then 40 against 35. So if you plot 20 against 5, that will be somewhere there. If I then plot 40 against 35, that's going to be somewhere there. If I then plot 60 against 55, that's going to be there. And then if I plot 80 against, what was it, 70. That's going to be there. And then we have 100 against 78. That's going to be there. And then if you have 120, was it? Yep, against 80, that is going to be there. And then you can draw a line to connect the points together, and that would look something like this. Use the graph to find an estimate for the percentage of office workers who took more than 90 minutes. So more than 90 minutes, if I go across my graph, 90 is going to be there. If I draw a line up from there using a ruler, I end up with something like so. It's not a very straight line, but that should actually, I'll do that again. So from there up till there, and then if I draw a line across, I'm trying to keep it straight, so that looks to me like it's 74 there. So that is going to be the total, which is 80 minus 74, which gives me 6. And they want it as a percentage, so that's going to be 6 out of 80 times 100. And in this case, the mark scheme will accept you reading any answer from the range of 76 to 72. So in this case, I had 74. And then the mark scheme for the percentage would accept any answer in the range of 5 to 10%. So this one does have a range on it. So OAB is a sector of a circle with the center O and radius 7 centimeters. The area of the sector is 40 centimeters squared. Calculate the perimeter of the sector. Give your answer correct to 3 significant figures. Now, to calculate the perimeter, the only thing we're really missing is this arc length. I'll call that x. If I have the arc length, all I need to do is add all the rest together. But they've given us the area. So you know that the area of a circle is pi r squared, and the area of a sector is x over 360 times pi r squared. Now, they've given us the area here, so I can substitute 40 is equal to x. So I'm going to just label this on here. I'll call this x, and I'll call this something else. I'll call this y. So x over 360, we don't know what the angle is, that's what we're trying to find, times pi times r squared. So that's going to be 7 squared, and that just becomes 49. So I can just write that's 49 there. And then I can collect some stuff together. So that's going to be 40 is equal to 49x pi over 360. And then I can move the 360 over and rearrange this for x. So that's going to be 40 times 360, divide that by 49 pi, and that gives me x. So that means the angle, if you type that into your calculator, is 93.5441292 degrees. Cool. So now that we have the angle, we can find the length of the arc. Now, to find the arc length, so I'll write that here, arc length. So to find what y is, essentially, the formula is going to be 2 pi r, which is the circumference, times x over 360. But now we know what x is, so we can do 2 pi r, which is 7, times 93.5441291, etc. Divide that by 360. And once you type that in your calculator, you get an answer of 11.42857. And then finally, now we know what this is, it's 11.42857. And we can now add all the sides together to get the perimeter. So that is going to be 7 plus 7 plus 11.4285 ... which then gives us 25.4 to 3 significant figures. Show that 6 plus square bracket x plus 5 divided by x squared plus 3x minus 10 over x minus 1 simplifies to ax minus b over cx minus d. Right, so let's start by writing this out. So that is 6 plus, let's keep the square brackets for now, x plus 5 divided by, don't need that there, x squared plus, let me just write that properly, 3x minus 10 over x minus 1. Okay, so the first thing I'm thinking when I see this, there'll be many different ways you can do it, is KCF method. So keep, flip, change. So this is a fraction inside the square brackets, right? It's being divided, and you can write x plus 5 is the same as writing x plus 5 over 1, if that makes it easier. So we're going to use that KCF method. So that's going to be 6 plus KCF, then that means you're going to keep the first one the same. We're going to flip the sign, so that's change the sign, so that's times, and flip the final equation, so that's x minus 1 over x squared plus 3x minus 10. Right, so that then leaves us with something like that, and then we can multiply that across. So that's then going to be 6 plus x plus 5, x minus 1, and now we've got one denominator, which is x squared plus 3x minus 10. Now with the denominator, it is we can factorize that. So this denominator right here can be written as x. So two numbers that multiply together to give us minus 10. That add or subtract to give you a plus 3. So that's going to be 5 and 2. And that should get us a plus 3. Okay, so now we can rewrite the denominator as 6 plus x plus 5, x minus 1, all over x plus 5, x minus 2. And just a hint here, there's a reason why I didn't rush into expanding this, because you can now see I can cancel this and this out. But if I started by expanding this, I would just make my life harder. So try not to expand too early. So we can now cancel that and cancel that out. So we are left with 6 plus, we can remove the square brackets now. So that then leaves us with that. Right, so again, we can make the denominators the same. I'll just use a different color for now to make it a little bit easier for us to see. So essentially we can, again, writing 6 is the same as writing 6 over 1. So we can multiply the top and bottom here by x minus 2 times x minus 2, and that x minus 2 is basically coming from here. So if I just change the color on this, just so you can see where that x minus 2 is coming from. And then that becomes 6 bracket x minus 2 over x minus 2 plus x plus minus 1 all over x minus 2, and that is 6x minus 12 plus x minus 1 all over x minus 2. And if you collect all the like terms together, that will give you 7x minus 13 over x minus 2. Moving on to the next one, a car moves from rest. The graph shows some information about the speed. Calculate an estimate for the gradient of the graph at t15. So at time 15, so that's that right there. We can put a point on the graph, which is there. So an estimate for the gradient. So for the gradient, we're going to go to that point and we're going to draw a line. Now you might be thinking, why does the line not look like this? It looks like this because we want it to be as close to the pattern in the graph. So we want it to be equal on either side. So that line looks to me like it's got an equal amount on the left and the right for the graph. So if I now draw a line through that, I should probably put it a little bit higher. And again, with questions like this, the answer will always have range, so there's no definite right or wrong answer. And again, then just pick easy points that you can use to calculate the gradient. So by easy points, what I mean is one easy point I see is right there, because it nicely touches the x-axis, and it also nicely touches the y-axis here, which is going to be 17.5. And then the other nice point I see is that one there, because it nicely touches the y-axis and the x-axis, so it'll just make my life a little bit easier. So in terms of the gradient, we're just going to go there, and then from the distance this way, it's going to be 10 minus, it's going to be 20 and 10, so that's going to be 10, the difference, and this is going to be 17.5 and 5, so that's going to be 17.5 minus 5, which is 12.5. And then for the gradient, it's going to be the change in y over the change in x, and that's going to be 10 over 12.5, and in this case my answer is 0.8, but the mark scheme accepts anything in the range of 0.6 to 1, so whatever fits within that range. Describe your answer to part A represents. So it's the change in speed against time, and that's known as acceleration. Work out an estimate for the distance the car travels in the first 20 seconds of its journey. Use 4 equal strips. So key bit here is the first 20 seconds and 4 equal strips. So if I go up, I'm just going to rub some of this work out. I'm going to leave my gradient though. Don't rub your gradient off because you'll need that for the answer to this question down here. But I'll just rub off this extra bit that I've done here. So it wants us to work out the speed in the first 20 seconds. So 20 seconds is still there. And it wants us to split the graph in 4 equal strips. So if you do 20 divided by 4, you get 5. So that means each strip must be 5. So this is going to be the very last strip. Now if I just draw that again, actually I'll start from the left. So it's going to be 5. Next one is going to be 5 again, which gets to 10. The next one is going to be 5 again, which gets to 15. The next one is going to be 5 again, which then gets us to 20. And now I can label these. Well, firstly, we'll just do that. So in order to work out the area, it needs to look like a shape. So these are all going to be trapeziums. And the very first one is more like a triangle. So I can always label these. So that's going to be A, B, C, and D. And now with this, the answer has to be accurate. There's no range given on the mark scheme, so you have to make sure you get this right. So for A, be as accurate as you can. So if you look at A, it's going up from 5, 6. So that point roughly there is about, sorry, it's going to be 2.5, 3. It's going to be the base times the height. So that's going to be 5 for the base. And the height to me looks there where I've put the dot, which is roughly here. It's going to be 4. So the first one is going to be 5 times 4. Divide that by 2 because it's a triangle, and that gives you 10. And then for B, now you want to use the formula a half, A plus B times height for the trapezium. And in this case, trapeziums look something like this, where this is the height, this is A, and this is B. So the height in all of them is exactly the same, which is going to be 5. So the height is always 5, and A is going to be 4, which is from there. And then B is going to be 12, which is from there. So that's going to be 4 plus 12 divided by 2, because we're timesing it by a half, and then times that by the height. That gives you 40. And then you're going to do the same for C and the same for D. So you have a half times A plus B, which is 12 plus 18, times 5, which is 75. And then for D, again, the same. It's a half A plus B, which is 18 plus 20, times 5, which is 95. And then we're going to add all of them together, and that gives us 220. Make M the subject of the formula. Whenever you have a fraction, you want to get rid of the fraction first. So we have F. And in this case, we have 2 M's. So at some point, we're going to have to factorize. So that's M minus 1. We're going to start by moving the M over to this side. So that's going to be F bracket M minus 1 is equal to 3M plus 4. We're now going to expand the brackets. That's Fm minus F is equal to 3M plus 4. Now you want to get all the M's on one side and all the non-M variables on one side. So let's move the 3M to the left. So that's going to be Fm minus 3M. And let's move the green F to the other side. So that's going to be F plus 4. Now we're going to factorize the M out. So that's going to be F minus 3. And now notice the M is almost on its own. So that means M is equal to F plus 4 over S minus 3. And it's a straight line with the equation 3y is equal to 4x plus 7. The point A has coordinates 3 minus 5. Find the equation of a straight line that is perpendicular to L that passes through A. Okay, so there's a few things you always want to remember before we even start this question. That y is equal to mx plus c, that's the equation of a straight line. And then the gradient of a perpendicular line is going to be m1, m2 is equal to minus 1. So that means the gradient of one line times the gradient of a line that's perpendicular to it is always equal to minus 1. So firstly, let's start with what we've given. We have a straight line L. So we have a straight line L, which has the equation 3y is equal to 4x plus 7. Now let's write this in the form y is equal to mx plus c. So we're going to have to divide each side by 3. So that's 4x plus 7. So now from this, we can work out the gradient. Well, the gradient is m. In this case, m is that value there. So that's going to be m for the line L is 4 over 3. Now I told you to find the gradient of a perpendicular line is going to be ml times this other line, which they haven't given a name to, but let's call it line x, is equal to minus 1. So now I know that ML is 4 over 3, and we're going to multiply by something to get minus 1, so it must be mx is going to be equal to minus 3 over 4. So now we have the gradient of mx. So if you look at this line x that we've created, the other line, the equation of the line is always going to be y is equal to mx plus c. We know what m is, so we're going to substitute that in. Minus 3 over 4x plus c. And we've also been told that this line passes through point A, so it passes through that. Now let's sub them points in since it passes through it. So we have an x coordinate and we have a y coordinate, so that is going to be minus 5 is equal to minus 3 over 4 times 3 plus c, so that's going to be minus 5 is equal to minus 9 over 4 plus c. And if I move the minus 9 over 4 to the other side by adding each side by plus 9 over 4, I end up with c is equal to minus 11 over 4. So that means the equation of this line can be written as y is equal to minus 3 over 4x minus 11 over 4. Moving on to question 17. There are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the small cubes to the large cubes is 4 to 7. The ratio of the number of red cubes to the number of yellow cubes is 3 to 8. Explain why the least possible number of cubes in the bag is 88. Now, when you have a question like this and you're not sure where to start with fractions, you can always start by looking at the totals. So 7 plus 4 is 11. 3 plus 5 is 8. And hopefully you can see the link between 88, 11, and 8. So, because you can do 8 times 11 to get 88, but that's not necessarily the answer. But sometimes just doing a few extra steps can help you visualize different things that you may otherwise have not seen. So in this case, the answer is that the LCM of 8 and 11 is 88. So all small cubes are yellow. So we've been told that all small cubes are yellows. Work out the least possible number of yellow cubes, large yellow cubes in the bag. So we have a ratio of small to large, which is 4 to 7, according to the question. And just get there. And then we have the ratio of red to yellow, which is 3 to 5, which totals to 8. Now we know in total there are 88. Is the least number we can have in the bag. We've been told that in the previous question. So in order for that to be 88, that means there must be 33 of these and 55 of these, because that gives us the 88. And if you're not sure how to work that out, you can just do 3 over 8 times 88, and then you can just do 5 over 8 times 88, and that will give you them two numbers. So now we know how many yellow cubes there are. We know there's 55 yellow cubes. So how many are small? Well, we know that this adds up to 11. We know that all small ones, which are 4 out of 11, out of the 88 are yellow. So we're going to do 4 over 11 times 88. That means there's 32 small ones, but we've been told all small cubes are yellow. So we know in total we have 55 yellow and there's 32 small. So that leaves us with 23. So that means there must be 23 large yellow cubes. The points A, B, C, and D lie on a circle. CDE is a straight line. Okay, you have BA, CB, angle. Okay, I'm just reading what's in the question. So BA is equal to BD, CB is equal to CD, angle ABD is equal to 40 degrees. Work out the size of ADE. You must give reasons for each stage of your working out. So hopefully, but you know, just by looking at this question, there's a few things you can figure out. So this is what they want us to work out. It's that angle there. It's a straight line. Angles on a straight line add up to 180. Key bits here are these two things there, so that just disappear. That means it's an isosceles triangle, which means this angle and this angle are the same. And then the exact same with this one. This angle and this angle are the same. So if we start by working out what we can, if you look at, again, you want to leave each an explanation for each step. So we have A, B, D. So that's a triangle. Is an isosceles triangle. So that means that the base angles are the same. So we can do 180 take away 40. That means the sum of the base angles must be 140, and each base angle, divide that by 2, is 70. So that's 70 there. That's 70 there. Let me just label this in red so we know what we're working out. So that's what we need to find for the question. So there's just one missing piece to this puzzle, because it is a straight line, so we just need to find what this green angle is, which is the same as this other green angle. And then once we have that green angle, we know all the angles on that line, and we can subtract it from 180. But we need one other piece of information for this triangle here, which is that angle there. So in order to get this triangle, you need to know that angles inside a cyclic quadrilateral add up to 180. So that means this plus this add up to 180. So we can write, let me just change color. So opposite, I'm not going to write the actually opposite angles in cyclic quadrilateral add up to 180 degrees. So that means 180 minus 70 is equal to 110. So now I know what this is. This is 110. And again, for the next four, C, B, D, it's an isosceles triangle. Angles in base angles are the same. So base angles are the same. And it's also good practice to label on. In this case, I've been writing the angles inside on the actual diagram. That it's also good practice to write what this angle is. So this is BCD, and the angle sign is normally that. And then in this case, it would be base angles are the same. So we're going to do 180, take away 110, which gives us 70. And we're going to do 70 divided by 2, which gives us 35. So that means that's 35, and that's 35 as well. And then finally, angles on a straight line. So hopefully you can now see we have this straight line here. Angles on a straight line add up to 180. So we know what this is 35, this is 70. So this must be 180 take away 70 plus 35. So finally, you can just write angles on straight line add up to 180 degrees. So that's going to be 180 minus 70 minus 35, which gives you 75 degrees, and that is your answer. Of course, write it neater than this, but you can see how I've gone through that step by step, labeled it all on the diagram, and they are marked for giving reasons at each stage. The diagram shows a triangular prism. The base ABCD is square. Now, there's a few things you'll know about a square, that all sides in a square are the same, all angles are 90 degrees. So worth bearing that in mind. ABE and angle CBE are right angles. I can see that on the diagram. Angle EAB is 35, that's labeled 2. M is a midpoint on DA such that, so we can draw that on. So DA is this line here. It's a midpoint, so it's going to be somewhere here. It's not a midpoint. M is a point such that DM to MA is 2 to 3. So it's going to be somewhere there, because it's saying this is 2 lots and this is 3 lots. So the point is going to be somewhere. If I draw that on, somewhere there. It's not necessarily in the middle. And then this side is going to be 2/3, 2/5, sorry, because it adds up to 5. These two add up to 5. And this is going to be 3/5. As a ratio, calculate the size of the angle between EM. I should also label this as M. So EM, so that's going to be EN, and then the base, so that's the base there. Okay, to 1 decimal place. So it looks like quite a tricky question, and it does require quite a bit of visualization. So the first thing I'll do is draw on the blue triangle that I've just drawn in there. So if I first get my highlighter to show you what I'm about to draw, it's that angle in there. So I'm going to draw that triangle out first. And actually I'll draw onto here. This is what we're trying to find. And I'll draw that in green. This is what the question's asking for. We'll call it X. It's asking us to find that angle. So if I grab my blue pen, And if I just draw that blue triangle, the exact same blue triangle that's there, and I'll label it in the same way so it's easy to follow along. So that's E, that's B, and that's M. We know that it's a right angle, so we can draw that on. So the only thing we know about this, actually, we don't know anything about this. We want to find angle X. And if I label a few things on, this is the height, we don't know. This is the base length, which we can call Y, which we don't know either. And then there's a long length on top. If we do need it for whatever reason, we can call it K. So at the minute, we don't really know anything about this triangle. So we want to, in order for us to find that angle inside, we'll need to know something about at least two sides. So I'm thinking maybe we can find, oh, I thought that was a highlighter then. I'm thinking maybe we can find this height here using this triangle because they both share the same side. They both have the same side in common. And with this triangle here, I know the angle and I know the side. That means I can figure out what this side is. So if I was to draw out this triangle here that I've highlighted, if I draw that out I'll draw it out in a different color. And I'll label the sides just so it's easy to follow. So it's going to be E, B, but this time on this left hand, it's an A. So this is the H, I'll label that on. And what we already know is that this is 35 degrees and this is 15 centimeters. And actually, we're to label it using SOHCAHTOA, we have opposite, hypotenuse, and adjacent, because that's a right angle there. We don't know anything about the hypotenuse, so we can ignore that. We want to find H, and hopefully you can see we have O and A, so that's saying we can use tan. So we now have tan 35 is equal to the opposite, which is H divided by the adjacent, which is 15. So H is going to be 15 times tan 35, which gives us 10.50311. So now we know what H is, so at least we've got something now. So that's 10.3511. Well, it's not 35, it's 50311. So we've got H. Now we just need to find one other side. It looks like it's going to be easier to find Y than it is going to be to find K. Again, if I highlight my highlighter, I'm now going to draw this triangle on that I'm highlighting. That's that base triangle there at the bottom. So that's going to be from M to B, B to A, and then A back to M. So if I draw that one on this side down here, so I know if I label that, that's B, that's A. I know B to A is 15 centimeters. That's M. I don't know what M to A is, but I know what the full length is. I know the full length is 15, and I know that this is going to be 3/5 of that because they've given me the ratios in the question. So if you work out 3/5 of 15, that's equal to 9. So that means that if I just move this out the way a little bit, so that means that this side is, let me just get up and back, 9 centimeters. And what I'm trying to find is this length, which, what have I called that? Y. So notice I've labeled all these, which then all link back to this main shape that we're working with. So that Y there at the bottom is the same as this Y here, because it's that length there. So I'm going to find out Y now. And in this case, I can use the Pythagoras theorem. So we have A squared is equal to B squared plus C squared. But in this case, it's going to be Y squared is equal to 9 squared plus 15 squared. And we don't want to know what Y squared is. We want Y. So that's going to be the square root of 9 squared plus 15 squared, which is 17.492. So now we also know what this is, 17.492. Now I have crammed it all up there, but now we can use that to work out what X is. If I now go back to SOHCAHTOA and I label these, so that's going to be the opposite, that's going to be the hypotenuse, and that's going to be the adjacent. Now we don't know anything about the hypotenuse, so we can ignore that one. But we do know something about the adjacent and the opposite. So we have an O and an A, so that's tan again. So in this case, if I write that up here, we have tan X is equal to the opposite, which is 10.50311. Divide that by the adjacent, which is 17.4925. And type that into your calculator, work out the inverse tan and to one decimal place, your answer becomes 31.0. The 0.0 is important because it does say to one decimal place. So moving on to question 20, we have a quadrilateral. So let's write down what the question's given us onto there first. So it's told us that C to D is A, it's told us that D to E is B, and M is a midpoint. Well, it tells us down here that M is a midpoint, so that means that this must be a half B, and this must be a half B because M is a midpoint. And then it's also told us that F to C is A minus B, okay, and then it says work out F to E. So in order for me to go to F to E, I don't know anything about this line, so instead I can go this way. And if I go this way, I know everything. I know that's A minus B, that's A, that's a half A, and that's A. So if I add all them together, I end up with F to E becomes A minus B plus A plus a half B plus a half B makes B. So in this case, the minus B and B disappear, and that becomes 2A. So I can label this as 2A. Now this question was quite straightforward. The next one is quite tricky. So we have X is a point on the line M, such that F to X, X to M is N to 1. So remember, with ratios, you can always work out the total. So in this case, the total is going to be N plus 1. So we can write that F to X, X to M is N to 1, which is the same as N over N plus 1 to 1 over N plus 1. We don't need this right now, but it's useful to know. And then it says this bit, then this bit here is key. They haven't told us that for no reason. CXE is a straight line, so let's draw that on. CXE is a straight line. Work out the value of N. So this is by far the trickiest question on this paper. So because they've told us CXE is a straight line, we do have some interest in CXE. So we'll first start by looking at C to E, which is going to be this plus this. And then we're going to look at C to X, which is going to be this plus this, or you can go this way. This way just seems a bit more. It's got 3 steps in it, whereas this way has only got 2 steps, which is a little bit easier, but you'll get the same value either way. So we're interested in C to X and C to E based on this information here. So C to E is going to be A plus B. And the way I've done that is, again, if I get my highlighter, I've gone that way. Now, for the other bit, which is C to X, that's going to be coming down here, which I know, and then going up here, which I don't know. So whenever you have something like this, where you don't know what this is, well, can you work out the full length? Well, yes, I can. What is F to M? Well, F to M is just going to be that. If I should have stopped, that disappear. F to M is going to be that, and this portion is just a fraction of what the full length is. So C to X is going to be A minus A plus B. So careful with this one because we are coming back down on it. And then it's going to be F to X. So plus F to X. I'll just write this like this for now to make it a bit easier. But we know that F to X is N over N plus 1 from here. It's a ratio or a fraction of the full length F to M. So now I want to figure out what F to M is. So I can do that on this side here. To go from F to M, it's going to be A minus B plus A plus a half B. And that simplifies to 2A minus a half B. So just to recap that, so to go from F to M, I've just gone there, there, and there. You could have even done this way. That would be easier. So it'd be 2 minus a half B if you just went this way. And now I can substitute that back into this. So that is minus A plus B plus N over N plus 1. And then F to M, which is 2A minus a half B. Okay, now if I expand that out, that's minus A plus B plus 2AN over N plus 1 minus BN over 2N plus 1. And now if I collect the like terms, so the A's and the B's, if I collect them together, So we have a, which will be 2n over n plus 1, and it's a minus 1 because it was minus a. And then for the b, we have 1 minus n over 2. Let me just make that a bit more to the left, over 2n plus 1. So that is what we are left with. Now, when you get to this stage, what you need to realize is that c to x and c to e are both straight lines that are following the exact same path. So if this is, say, for example, c to x, and say this is c to e, they are both following the exact same path, right? One line is just a bit longer than the other one. So if this line is a plus b, we know that because we calculated that right here. So if that line is a plus b, this line will also be some multiple of that line. So this is going to be something like ax plus bx. So for example, this line could be 7a plus 7b, or it could be 9a plus 9b. And the point being, it's a multiple of the coefficients of the other vector. So notice that it's 7 and 7, or 9 and 9. Both numbers must be the same, which then means if I come back to this a value and this value here must be the same, because it can't be 3a and 6b, for example. They both must be the same, which means that this equation must equal this equation. So if you make these two equations equal, I am going a little bit off page here now because it'll be easier for you to view down here. So if I make these two equations equal to each other and solve them, I will get my value for n. But hopefully you can see why I've made them equal from my explanation above, rather than me just diving into it. And this is a tricky question. So the first thing we can do is get rid of the 1, so we can add 1 here, add 1 here. So that gives me 2n over n plus 1 is equal to 2 minus n over 2 bracket n plus 1. So now we have this. A simplification I can see straight away is if I multiply each side by 2, I can make the denominators the same. And you'll see what I mean when I do this. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. So that's 4n over n plus 1 is equal to 2 bracket, well, not 2, because I'm multiplying it by 2. So that's 4 bracket 2n over 2n plus 1. And now what I can do is cancel these two out. So that leaves me with the same denominator now on each side. So we now have 4 over n plus 1 is equal to 4. I can multiply the top and bottom by n plus 1, so that'll be n plus 1 there, minus n all over n plus 1. If I expand the brackets out, so that's 4n over n plus 1 is equal to 4n plus 4 minus n all over n plus 1. Now I can multiply each side by n plus 1. So if I multiply this side by n plus 1, I can cancel this out. And if I multiply this side by n plus 1, I can cancel this out. So we're left with 4n is equal to 4n plus 4 minus n. If I subtract 4n from each side, I'm left with 0 is equal to 4 minus n. And if I move the n to the other side, I'll end up with n is equal to 4. Now, like I said, this is quite a tricky question, but hopefully you could see from my explanation up here why we've done it the way we've done it. As always, I hope you found this video useful, and I'll catch you in the next one.